In lesson 2.2, you are going to be able to solve one-step equations in one variable by using multiplication or division. So building off of our previous lesson, remember that we solve equations by using inverse operations. The inverse operation to multiplication is division, and the inverse operation to division is multiplication. Why? Because these are the operations that undo the other one. Okay, so let's look at example 1. When you look at this equation, you can see, and I'm going to rewrite it just so I have room next to it, p divided by 5 equals 10, right? This bar means division, so the opposite of dividing by 5 would be to multiply by 5. I rewrote my equation because I like to multiply right next to it, because then I can see that it's, times 5 and divide by 5, it's really like having 5 over 5, right? This is like a fraction, and if it helps, you could put this even like over 1, and we can see that we have a 5 on top and a 5 on the bottom, and they cancel each other out. Now, you don't have to put that over 1 there. Remember, any number can be written over 1. So I'm going to erase that, but I just wanted to point out that it's the same, okay? So these cancel. I would recommend that you do write the multiplying by 5 next to the p, just like that, because I do want you to see this as fractions, and it will help us with our later problems in today's lesson as well. These cancel each other out, and you're left with p equals, and 10 times 5 is 50. Just like the previous lesson, always check your answers. You don't want to miss a problem like this because you were a little lazy and didn't actually check your answer. Put 50 in for p into the original equation and make sure you actually check. 50 divided by 5 is 10. 10 equals 10, so I can see this works out. So my solution, or my value for p that makes the equation true, is 50. Try number 2 and 3. They're very similar to number 1, so pause the video, try number 2 and 3, and then press play to go over them. Okay, so hopefully you have tried number 2 and 3 at this point. I showed my work down below here. I rewrote the equations so that I could write the multiplication next to the variable, and I hope you did the same. All right, I can see that I want to multiply by 3. Notice the placement, because it's like having 3 over 3. They cancel each other out. 3 divided by 3 is just 1, right? So I get a 1y, or just a y. Multiply both sides by 3. Check your answer. You should get y equals negative 39. On the next one, I multiply both sides by 8 because 8 divided by 8 is a 1. Those cancel each other out and you're left with C. And 7.3 times 8, multiplying with decimals, guys, I had to do my work over here, all right? So 8 times 3 is 24, carry the 2. 8 times 7 is 56, plus the 2, which is 58. And then there was 1 decimal spot, so I went over 1 decimal spot. And I really, truly checked my answer. If you have any questions on those, please remember to ask them in school at some point. All right, let's look at the next set of examples. I'm going to skip 4 and 6. I'm going to have you try those, but let's do 5 together first. Again, when you're solving an equation, make sure you identify the variable and figure out what is happening to your variable. So here's my variable right here, and what do I see happening to it? Well, right next to the variable, I see a 0.5, right? So if there's nothing in between, if I just have 0.5 y equals negative 10, and I'm only rewriting it just so it's a little bigger, there's nothing happening in between here that I see, right? So we know that that has to be multiplication. So you can put the multiplication symbol in, but we know by now that the coefficient is being multiplied by the variable when we don't see an operation. The opposite of multiplication is division. So I'm not going to do the division sign, I'm going to do the fraction bar. I'm going to divide both sides by 0.5. Okay, so divide both sides by 0.5, and again, I recommend that you use the division bar. Keep your fraction skills really up to date and practiced, and it's easier to think about these problems like fractions. Multiplying by 0.5 and dividing by 0.5, these cancel each other out. They're like having a 1 right there. So this is really just 1y or just y. Don't write the 1. Now you have to do negative 10 divided by 0.5 or 1/2. So think about this. A negative divided by a positive is a negative. And if you had 10 pizzas and you wanted to know how many halves you have, you would have 20, right? If you're not sure how to do that, you could do the long division on the side. You could do 10 divided by 0.5, all right? Then we would move this decimal over so that we're dividing by a whole number. And 10 would have a decimal right here, so we would have to move it over to match. However many spots you move this decimal over to the right, you do the same on the inside. So we would really be doing, this division would be the same as 5 on the outside, and you would divide 100 by 5. This was 10 and this was 0.5, but if you move both the decimals over 1, your answer is still the same. Well, that's a little easier to think about. 100 divided by 5 is 20, right? So y equals negative 20. Check step, don't skip it, let's check it. I shouldn't box it in until I check it, but I'm pretty sure I'm right. So if we have 0.5 times 20, times negative 20, I'm checking to see, does that equal negative 10? Again, you can think of decimals as fractions too, so remember that 0.5 is a common fraction. It's really 1/2, so what's half of negative 20, right? It might be easier for you to think of that. I don't care how you check it, I just want you to check it. So half of negative 20 is negative 10. Negative 10 does equal negative 10. That is a true statement. So try 4 and 6, pause the video, press play to go over them after you've completed them. All right, so hopefully you've tried 4 and 6. Here's my work and my answers for these two. Both of these are very similar, and I chose to do the middle one because of the decimal. But you are dividing both sides by 4 on problem number 4, and you are dividing both sides by 15 on problem number 6. Check your work. If it checks out, circle your answer for me, but make sure you did show me a check step. Okay, so let's go on to 7 and 8. These look a little harder. What is happening to your variable in 7? So I'm going to rewrite them again so I can write next to them. I can see that B has a 1/5 in front of it. So I know that there's multiplication right there. Now, typically, guys, I would say the opposite of multiplying is dividing, right? So I would maybe show that I'm going to divide both sides by 1/5. But that looks very messy, right? Oh, we've got a fraction divided by a fraction. Remember your fraction rules. You would actually keep, switch, flip. So you would end up multiplying both sides of the equation by the reciprocal, right? In order to do this fraction division, you would have to keep this. You have to switch division to multiplication, and you have to flip 1/5 to 5/1. So in 7th grade, we may have showed our work like this. But in 8th grade, I'm going to take it a step back. And remember, the goal is to get this to be a 1b. I just want to end up with b. I only want to have that left, okay? So let's think about this with our knowledge with fractions. What could I multiply by that would cancel this 5 out? Well, if 5 is on the bottom here, if I put a 5 up here, those will cancel, right? Yeah. And then if I wanted to cancel this 1 out, I could put a 1 down here, and those would cancel each other out as well, right? So do you see that we would have these canceling and these canceling, and we would be left with b? That works then. That's what we want to do. It's a little easier to think about it this way. Instead of dividing by a fraction, multiply by the reciprocal. 1/5 is the reciprocal of 5/1. So I'm going to actually multiply both sides by 5/1 in order to get my b isolated. And we'll do the next one too together, so don't worry. So we get b equals, now how do we multiply fractions? We multiply straight across. 5 times -1 is -5. 1/1 times 4 is 4. So we're left with -5/4. I don't have a preference on whether this is a mixed number or not. So you could write it as -5/4, so you could write it as -1 and 1/4 equals b. Both would be acceptable. Let's show a check step here. If I did 1/5 times -5/4, let's make sure this works. Do this multiplication over here. If I multiply straight across, I would get -5/20. If I simplify, I could cancel out a 5 in both the top and the bottom. Negative 5 divided by 5 is a negative 1. 20 divided by 5 is 4. So I do get negative 1/4 equals negative 1/4. Both of these answers would work. I would keep it as negative 5/4, but some people really like mixed numbers. All right, let's look at 8. J is in the numerator here, all right? So we see that we have 4J over 6 equals 2/3, all right? But this is really the same as 4 times J, and we're dividing by 6. It doesn't matter whether that's under just the J or just the 4 or both. So I'm going to rewrite it as 4/6 times J. You couldn't do that if the variable was in the denominator. Okay, you could not do that if the variable was in the denominator. But this is the same thing. Why? Because if I multiplied these fractions, I would just put a J over 1 and it would end up in the numerator. If I multiplied this straight across, this would be like J over 1, and add 4 times J and get 4J, and 6 times 1 and get 6. So we can separate it. All right, so if you see a fraction being multiplied by your variable, it's easier and quicker to multiply by the reciprocal to cancel it. The reciprocal to 4/6 is 6 over 4. So do that on both sides. 4's cancel each other out, 6's cancel each other out, and we're left with J. That's why it works so nicely. Multiply by the reciprocal. Multiplying these fractions, you can choose to reduce them now or reduce them at the end. 6 times 2 is 12. 3 times 4 is 12. What's 12 divided by 12? Don't say 0. Hopefully you said 1. Check it. We would have 4 times 1 over 6. And we're checking to see, does this equal 2/3? 4 times 1 is just 4. 4/6 reduces to 2/3. So 2/3 does equal 2/3. I know I'm going fast, so please ask questions in school if you have them. Pause the video, try number 9, then press play to go over it. Okay, and number 9, the reciprocal would be 6 over 1. When you multiply both sides by 6 over 1, you should get W equals 612. Make sure you check it. Last problem. The distance in miles from the airport that a plane should begin descending. So the distance that the plane should begin descending divided by 3 equals the plane's height. Okay, so distance, I'm going to write this into words. Distance that the plane should begin descending divided by 3 equals the plane's height above the ground. Oh, but catch that last part, the height above the ground in thousands of feet. So when it says something like that in thousands, you want to make sure that you only use the number that represents the number of thousands. Okay. So this is just in words right now. It's not an equation yet, but it helps me to keep my thoughts straight. If a plane is 10,000 feet above ground, write and solve an equation to find the distance at which the pilot should begin descending. So D, or the distance to begin descent, is my variable. I know that because that's what it tells me to write an equation about. So I'm going to have D divided by 3 equals. My height of the plane is 10,000, but you have to put the height in thousands. So how many thousands, how many 1,000s do you have? You have to think about that carefully. You're not putting in 10,000 right here. You're just putting in 10 because I have 10 1,000s. There's your equation. Now we know the opposite of dividing by 3 would be multiplying by 3. These would cancel. I'm left with D equals 30. And always label a word from the answer. So it's D is the 30 miles from the airport is when I should start my descent. Now I know I went through that fast. See if it makes sense to you. Ask questions in school if it does not.